Hello, this is Dr. Mears. Today we are going to be continuing learning about exponential functions using our slide deck. So this is Exponential Models Part 2. Let us look at these functions. We have three functions here. The f of x equals cutoff. I apologize. So the first function, which is the original, is f of x equals 1/2 to the x. Then we have a second one that says f of x equals 3 times 1/2 to the x. Then we have the last one that says f of x equals 1/3 times 1/2 raised to the power of x. Our question is, what do you notice and what do you wonder? So when we start with the original function, which is this function right here, and move to multiplying by 3, so it's this function right here, so we actually multiply 3 by our original function that we started with, we see that it stretches, sort of stretched up. So it kind of stretches up. Stretch. When we go back to our original function and then multiply it by 1/3, we see that it shrinks downward. Shrinks downward. So let's look at this even further. F of x equals 1/2 x to f of x equals 3 times 1/2 x is called a vertical stretch. F of x equals 1/2 to the x to f of x 1/3 times 1/2 is called a vertical shrink. This means that f of x equals, when we include a number times our a to the x, it controls the vertical stretch or vertical shrink. So when this number is 3, it's going to stretch. When it's 1/3, it will shrink. So we're introducing another variable here, which is going to represent a number, and that's the variable k. So here, this was k, this was a to the x. Now our k here is really going to be 1 times 1/2 to the x. So this is k and this is a to the x. I'm going to explain that a little bit further. And then here, this is k, was 1/3, and then this is a to the x. So we're introducing that today. Okay. Let's try this one. Let's compare two exponential growth. This shouldn't be 2, this should be 3. I actually added it on. I first started with those two. I said, let's look at the other one too. Okay, so we have the original, 2x. Then we have 2x plus 4. Let me restate that. We have the original f of x equals 2 to the x. Then we have f of x equals 2 to the x plus 4. Then we have f of x equals 2 to the x minus 4. So notice here we added 4 and here we subtracted. Now on your slide deck, you'll be able to click and drag the equation next to its graph. I can't do that, so I'm just going to write them in. So let's start with the original. The original is going to be f of x equals 2 to the x. That is going to be this red one. This is because our horizontal asymptote right here is going to be the line y equals 0. And the line y equals 0 is actually our x-axis. So it starts with the y-intercept at 0. So this red one right here, this is f of x equals 2 to the x. Let's look at f of x equals 2 to the x plus 4. So when we start with an asymptote of y equals 0, we're actually going to move the asymptote up. And remember, this doesn't cross it. I'm trying to be perfect. To 4. So our horizontal asymptote is going to be y equals 4 because we moved it up 4. So that means that we have a y-intercept of 5. Here we had a y-intercept of 1. Let's see what happens when we do f of x equals 2 to the x minus 4. So you're right in your thinking. We're going to be going back to the original, and then we're going to be moving this horizontal asymptote down 4. Oops. I'm trying to get it so it doesn't look like it touches. So a horizontal asymptote, or that imaginary line in which our graph will not cross, is dropped down to y equals -4. So when we add these numbers in, we see that it's going to either raise or lower the horizontal asymptote. Now this horizontal asymptote was 0. So this is really plus 0. So when there was no number there, we put the 0 in. So this represented the horizontal asymptote of y equals 0. This represented the horizontal asymptote of y equals 4. And this is the horizontal asymptote of y equals negative 4. Now we can write these in function form. So you're going to see me use f of x equals 4. You're going to also see me use f of x equals 0. And you're going to also see me use f of x equals negative 4. Either way it can be written, I'm going to be using the function form, which, like it, it's a little bit fancy. So let's look to see what we have now. Now we have f of x equals k, remember that controls the vertical stretch or shrink, times a to the x. Now we have plus c. The c controls the shift up or down of our horizontal asymptote, which controls the graph. Let's write that in. C controls the shift up or down of our horizontal asymptote. So now, I think this is one of the most important slides because it's going to tell you what each part of the function does. So let's explore it. So first, we see that this is going to be exponential growth if a, so we're talking about the a number, if it's greater than 1, then the curve increases. So if this number in for a is going to be 2 or 3 or 4, then the graph is going to increase. It's going to be exponential, so it's going to look like this. It's going to be exponential decay if our number for a is between 0 and 1. So if a is between 0 and 1, we're looking at 1/2 or 0.5 or 1/3, then the curve is going to decrease and look like that. So that's our a number. The horizontal asymptote is always going to be at c. So remember, this controls the horizontal asymptote. This is the imaginary line the curve never crosses. You can write it as y equals c or f of x equals c. And lastly, the y-intercept. And that's where it intercepts the y-axis. And we're going to see the y-intercept happen at 0, which is your x value. Here's your x value is 0. Your y value is going to be adding together the k number and the c number. So when we add those together, it will give us our y-intercept. This is where the graph crosses the y-axis. We also call this our initial or start point. We're going to keep exploring this. Now, what you're going to come to is this table right here. What we're going to do is we are going to find the values of k, a, and c. And when we do, we'll be able to find where it intersects the y-axis. We'll be able to find the asymptote, and we'll be able to tell if it's increasing or decreasing. And so we're going to go through these step by step, and we're going to fill this table out. However, all the answers are on this table, so I am just going to start with this first one right here. So the first one we're going to start with is f of x equals 3 to the x. Okay. So here is our equation that we're going to be working with. F of x equals k times a raised to the power of x plus c. What we have to do is we have to find out what k, a, and c are. In order to do that, we have to fill in the missing information. So if we look, we don't have a k. There's nothing there. We do have an a, and that is 3. We don't have a c. So in order to fill those in, we have to remember a couple rules. If there is a number missing in front of the variable, it's linked by multiplication, it's going to be 1. So if there is no k in front, we're going to take it as 1. If we have no number, we know that we're going to be adding 0. So these are two things that you really do have to remember. If there's no number for K, it's going to automatically be 1. If there's no number for C, it's automatically going to be 0. Filling those in, I just rewrote the equation underneath so that you can clearly see K is 1, A is 3, and C is 0. K is 1, A is 3, and C is 0. Now we can go find our y-intercept, equation of asymptote, and whether it increases or decreases. Our y-intercept, that's at 0, comma, K plus C. This is a point, so let's find it. So it's 0, K is going to be 1, plus C is going to be 0. So we're going to have our y-intercept at 0, 1. So on the y-axis, it crosses the graph at 0, 1. The equation of the asymptote, that's f of x equals c. C was 0, so we just put f of x equals 0. Let's find if it was increasing or decreasing. Remember, increasing or decreasing, if a is greater than 1, it's increasing. If a is between 0 and 1, it's decreasing. So let's look at our a. Our a is 3. Well, 3 is definitely greater than 1, so we know that it's going to be increasing. So now we can fill all of this out on our table. So here's our table. So you can go back and you can say, okay, the value of K is 1, 3, the value of A is 3, C is 0, and then fill out your y-intercept, your asymptote equation, and whether it was increasing or decreasing. Let's now move to the second one. F of x equals 2 to the x plus 3. Okay. F of x equals k times a to the x plus c. So again, I wrote down the equation, but matching everything up, I'm noticing I'm missing k. Remember, what happens when we're missing k? What do we have to fill in? You're right, we have to fill in that 1. So when we're missing k, there's no number in front being multiplied, it's going to automatically be 1. So this is 1 times 2 to the x. And you know I like to write parentheses, so sometimes I'll just put parentheses like this, plus 3. So now we have our k, we have our a to the x, and we have our c. So our k is 1, our a is 2, and our c is 3. Now that we have these numbers, we can find our y-intercept. Y-intercept is a point, the point where it crosses the y-axis. Well, x is always going to be 0. We have to take the numbers of k and c, 1 and 3, and add them together. Please do not forget to add them together. It's a point, so the point where it crosses the y-axis is 0, 4. Crosses y-axis at 0, 4. Okay, let's find the equation of the asymptote. F of x equals c, f of x equals 3. And let's find if it's increasing or decreasing. So we have to look at our a value. Our a value is 2. 2 is definitely greater than 1, so we know that it is increasing. So now we can go and fill that out in our table. 1, 2, and 3. 0, 4 is where it crosses the y-axis. Our asymptote is f of x equals 3, and it is increasing. Let's now go do the next ones. I am, for this video, going to be doing all of these with you. If you would like to try them yourselves and then come and check the answers, that is great. If you feel that you have a handle on it. If you want to keep watching, please do so. I'm going to walk through all of them with you. Okay, the next one, f of x equals 2 times 3 to the x plus 1. This is really nice because we can clearly see we have the k, we have the a, we have the c ready to go. So k is 2, a is 3, and c is 1. I love to write down all of my information that I have separately because it makes doing these parts easier. Let's find our y-intercept. Okay, well our x is going to be 0. I'm going to add k and c together, so that's 2 plus 1. Please do not forget to add them together. My answer is this, 0, 3. That's the point it crosses the y-axis. All right, let's find the equation of the asymptote. F of x equals c. C is going to be 1. And let's find if it's increasing or decreasing. Let's look at our a. A is 3. 3 is definitely greater than 1, so it is increasing. You can now go back to your table and fill that one out on your table as well. If you need to pause this, please pause it, or even slow me down if I'm going a little too fast. Oh, did I make a mistake here? Hold on, let's check this out. Because my y-intercept here, I said is 2. However, what did I get wrong? The value of k. Let's fix that. So this is 2, and this would be 3, because 2 plus 1 is 3. Thank you very much for stopping me to let me know that I put my numbers in my table incorrectly. I must have been going a little too fast, but this is how our brain grows, through making mistakes, and I caught it because clearly k is 2, making sure k is 2, and making sure my y-intercept 2 plus 1 is 3. Okay, my value of c, I just want to check everything, is 1, and yes, it increases. Okay, little mistake, but we're learning from it. All right, let's go to the next one. Should have double checked, triple checked my work. Okay, the next one is 3 times 0.5 to the x minus 2. Again, really nice. We have all of our numbers. K is 3, A is 0.5, and be careful, C is going to be negative 2. Please be careful with your negatives. Let's look at the y-intercept. We're going to add K and C. And when we do that, we're going to be adding 3 plus a negative 2. 3 plus a negative 2 is negative 1. Don't forget to combine these. Asymptote, f of x equals negative 2. Please be careful of your negatives. Let's see if it's increasing or decreasing. All right, so let's look at our A. Our A is 0.5. 0.5 is not greater than 1. So it's definitely in between 0 and 1. Oops, I'm sorry, couldn't see that. Definitely in between 0 and 1. It's right in the middle. So we definitely know it decreases. Okay, let's check the table to make sure I'm filling it out correctly. All right, so we have 3.5 and negative 2. 3 plus negative 2 is 1. F of x equals negative 2, and we found it is decreasing. Beautiful. Okay, let's move on to the next one. Here we have f of x equals 0.5 to the x. So we have some things missing. Okay, what do we have missing? We have the k missing. Remember, when we're missing the k, it's going to be 1 times 0.5 to the x, okay, plus c. Remember, when we're missing that plus c, we're going to be doing plus 0, because when we add 0 to something, it stays the same. When we multiply 1 by something, it stays the same. So 1 times 0.5 is going to stay the same. All right, here we go. So our k is 1, our a is 0.5, and our c is 0. 1, 0.5, and 0. Let's find our y-intercept, 0. Then we have k, which is 1 plus 0. Please do not forget to add. Our y-intercept is 0, 1. Equation of our asymptote, f of x equals c, which is 0. Let's find if it's increasing or decreasing. Looking at our a, it's 0.5. 0.5 is in between 0 and 1. We know it's definitely not greater than 1. So it decreases. Let's go to our table to make sure everything is filled out. 1, 0.5, 0, 0, 1. F of x equals 0, and it is decreasing. Beautiful. Okay, let's go. Next we have f of x equals 0.4 to the x minus 2. So what are we missing here? You're right, we're missing the k. It's being multiplied, so we have to put in that 1 times 0.4 to the x minus 2. Okay, so our k is 1, our a is 0.4, and our c is negative 2. Please do not forget that negative 2, very common. Let's find our y-intercept, 0, k, 1 plus negative 2. So be careful. This is actually dropping it down now. So our asymptote was dropped down to 0, negative 1. Actually, y-intercept, I'm sorry. Our y-intercept was dropped down to 0, negative 1. What's our asymptote? Our asymptote was actually f of x equals negative 2. So our asymptote was dropped down lower to 2, negative 2. Okay, let's see if it's increasing or decreasing. 0.4. Well, 0.4 is definitely not greater than 1. 0.4 is in between 0 and 1, so it is decreasing. Let's make sure we filled out our table correctly. We have 1, 0.4, -2. Our y-intercept is 0, -1. Our asymptote is f of x equals -2, and it is decreasing. Okay, last one, everybody, on this table. Hopefully you're catching along. You might even want to pause here and try the last one yourself to see if you got it right, if you were doing these all with me. And here we go. We have our equation f of x equals 4 times 2 to the x minus 5. Really nice. We have all of our numbers here. So our k is going to be 4, our a is 2, and our c is -5. Look at that's really funny. When I was writing this, everybody, this should be c. This should be plus c, shouldn't it? Writing just a little too fast. So we have our k, our a, and you knew that was going to be our c. Okay, so our k is 4, a is 2, and c is -5. All right, so we have 0, k plus c, so 4 plus -5, making sure that we combine those. 4 plus -5 is -1. Here's where it crosses the y-axis. Let's see where our asymptote is. Our asymptote is at -5, so f of x equals -5. Let's see if it increases or decreases. Our a is 2. 2 is definitely greater than 1. 2 is definitely greater than 1. Check, so it's going to increase. Let's make sure I filled the table out correctly, and here we go. We have 4, 2, and -5, or our y-intercept is -1. Our asymptote f of x equals -5, and it is increasing. So here you go. I should have checked that one, I'm sorry, but here's the table completed. If you have questions, right now would be a great time to stop the video and ask me questions. I know that we're doing this together, so let's move on. Okay, we are going to be graphing. So we are going to be using our knowledge of the exponential function to sketch the graph. So sketching just means we're going to put down the information that we have into a graph form and then sketch it. It's not going to be perfectly precise with all the points on there. It is going to be a sketch. So the first thing that we have to find is all of the information that we found before, and that is going to be our a, k, and c. So I just wrote f of x equals k times a to the x plus c. Then I filled in our missing information. We were missing the 1 and the 0. So k is 1, a is 3, and c is 0. I calculated our y-intercept to be 0, 1. Our horizontal asymptote to be x equals 0. And then, because 3 is greater than 1, it's increasing. We did this example. This was the very first one that we did in the table. I just wanted to review it one more time in case you paused the video. So now what we're doing is we have to sketch the graph. If you would like to draw a graph on a note piece of paper, that's fine. I know you're working in a slide deck and it's difficult to draw a graph. So right now I suggest getting a piece of paper and drawing the graph with me by hand, and then keeping that piece of paper handy in a notebook somewhere you can find it. Hopefully you have a math notebook. All right, so let's look to see what we need. First, we need the y-intercept right here, number 1. We need to know where this graph is going to cross the y-axis, or in our case, the f of x. Remember, this can also be the y-axis. So the y-intercept is at 0, 1. So let's make that point. Kind of like making a linear equation. Remember, we always start at the y-intercept. We always started at b. Same exact concept. Now we're just doing it using exponential functions. Okay, now the equation of the asymptote, this is important. This is that invisible line that the graph won't cross. The curve will not cross. So this is f of x equals 0. Remember, f of x equals 0 is your x-axis. So I'm just going to draw a nice thick line representing my horizontal asymptote on f of x equals 0, which is my x-axis. So here is that invisible horizontal line my curve will not cross. So that's number 2. Number 3 is whether it's increasing or decreasing. Now, because a was greater than 0, it's increasing. So we know it's going to look like that. And that's why I started the slide deck with what the graph looks like. So now we know it can't cross this imaginary line, and it increases. So we're going to draw it. We're just going to sketch it in. and you're going to try to get as close as you can to that line without passing. And this is what I mean by a sketch. It's not perfect. I'm just showing the qualities that you picked out, the characteristics that you picked out, and we're able to see where it crosses the y-axis, where its horizontal asymptote is, and what it looks like if it's increasing or decreasing. And this is what I mean by sketching a graph. Okay, so let's try sketching this graph. This is, I believe it is one on our chart. It is actually the second one that we did. You have the information and how to get. We got the K, A, and the C here. So K is 2, A is 3, and C is 1. If we add the K and the C, 2 plus 1, we get the y-intercept of 3. The equation of the asymptote, f of x equals 1. I also put y equals c here, just remembering that y is f of x. This is the y. And it is increasing because 3 is greater than 1. So let's sketch the graph. First, we need a start point. Start point's always on the y-axis or the f of x axis. So here's our start point. We're always starting on this one. All right. Where's that imaginary line? The horizontal imaginary line that it can't cross. That's going to be at 1. F of x equals 1. So we're going to go to the f of x equals 1. That's right here. And we're going to draw that line in. So this is f of x equals 1. So this line, the graph, will never cross. It is a very sad story in mathematics. So it's increasing. So we know that the graph is going to have that pattern. We know where it crosses. We know where it can't cross. So let's draw our graph in. And you're going to want to try to get, my curves aren't that perfect. I'm sorry. Hopefully your curves are better. You're going to want to kind of, you know how it goes, curve down and then back up. Okay. So there's our sketch of our graph, where it crosses the f of x, where it doesn't cross, and what it looks like. Okay. Now, extending our knowledge, what we're going to have to do is talk about or tell me about the graph of this exponential function. And it's y equals 3 raised to the negative x. This could have been f of x, but you know, I'm switching back and forth to get you used to seeing the y there and seeing the f of x. So we have to tell me a little something about it. And what I'm going to ask you to do is I'm going to ask you to first make a table. If I say anything about making graphs and you don't know where to start, go to a table. Make a table. So what I'm meaning by table is this. Let's make a table first. We know that our x is our L1, our f of x, or in this case it is y, I'm using y, is our L2. Because if you want to know about a graph, why not graph it in your graphing calculator? I just used -3 to 3. I always like to include 0, so I went -3, -2, -1, 0, 1, 2, and 3. And then what I'm going to do is substitute the numbers in. But we need to be careful because we have a negative x. So I showed you how to do all of these. We have y equals 3 raised to the negative. However, we're putting in a -3. So if you want to, if you understand the concept of a -3 is a real +3, that's fine. But I'm showing you physically that this negative stays there, and then when we substitute a -3, we now have double negatives. You can totally do that on the calculator. So if you have 3, and then remember this is the exponent button right here, to the, and then you know the x was negative, so -3, it's going to give you 27. That's fine. However, you could have said 3 to the third. Absolutely fine. You're still going to get 27. So what I did is I put all my numbers in and I showed my work for you guys. I even put a -0 in. Not needed, but I wanted to show you how this negative stayed. So I put in all of these numbers and I made a table. And then in my graphing calculator, I'm hoping that it's still there, I did stat edit. Let's do that one more time. So I did stat, and then I want to edit, and I put my numbers in, and then I pressed, you got it, zoom 9, and I got this. I should actually take that out. I apologize. That was another line from another problem, so let's just clear that out. Okay, now we can go to our graph. There we go. So I can now clearly talk about the graph of this exponential function. I could talk about how it's decreasing. I could talk about how I believe that the horizontal asymptote will probably be at y equals 0. So let's investigate this a little bit further. So I used my GDC to graph, and then I just sketched it. We know it's decreasing. I actually looked to see on the calculator, if you press the word trace here, you can get a little blinking dot, and you can use your arrow key, your right arrow key, and your left arrow key to go back and forth. I found right here, look at this, 0, 1. That is my y-intercept. So we know the y-intercept is 0, 1. I'm going to believe that the equation of the asymptote is f of x equals 0, or in this case using y equals 0, either one works. And you can see that because if this was plus c, this would actually be plus 0. And if we put a k in front, the k would be 1. So I am right by assuming that the y-intercept is 0, 1, and that the equation of the horizontal asymptote was f of x equals 0. So conclusion, let's make a conclusion because this reminds me of something that we've done. In conclusion, y equals 3 to the power of negative x is really y equals 1/3 x raised to the power of x. The negative exponent represents the reciprocal of a. Dun, dun, dun. So what does that mean? That means that when we had y equals a to the negative x, we actually have y equals 1 over a to the positive x. It flips it, so it turns it into a fraction. And if you like to see this even flipped even more, our a, to turn anything into a fraction, we put it over 1. So this, in all actuality, is a over 1 raised to the negative x. When you want to take that negative away from that exponent position, you actually have to flip the inside. There we go. Okay, so that has been extending your knowledge. That is called an exponential rule. We will start to use exponential rules. However, we're looking at models right now, so we're not going to be getting into the algebraic exponential rules that you know of. And I also wanted to point out one last thing, and that's going to be, we saw a graph of exponential decay. And it was this one from part 1 that I wanted to point out to you. You saw that there was this f of t equals 2, and then this isn't really clearly written out. This is actually f of x equals 2 to the negative t divided by 2. That's really what that was. There was a negative in that exponent. So this is decreasing. And so if we took that negative out of the exponent, this would really be written as f of x equals 1/2 to the positive t divided by 2. So I just wanted to come back right to the beginning to say, you know, it looks like a is greater than 1 here. Shouldn't it be increasing? Nope. That's because this negative was in the exponent spot. And that negative in the exponent spot really makes this go from 2 to 1/2. And that's extending your knowledge. Hopefully this helped. Maybe some pauses, some breaks, some questions in the middle of it. Learning experience. Thank you very much for listening.